Hi everyone, we are back on moments. This is mechanics. We are looking at moments for the past 2 days, and we did say that the moment is the turning effect a force has around a pivot. When you apply a force around a pivot, that turning effect which the force produces is what we call a moment. I've already solved some problems yesterday. We'll continue today. We are looking at problems here. Two problems we have here on the board. And we are asked to find the sum of the moments. We are now applying different forces on an object, and then you are asked to find the sum of those moments on that object. Question reads as, for each of the following light rods, these are light rods, they want to make the mass of the rod to be negligible, to be small for calculation purposes. For each of the following light rods, find the sum of the moments about x. This point here, find the sum of the moments about x. This is the point here, you are asked to find the moments about. And on this second diagram, second problem here, you have to find the moment about x here. You have a force of 15 newtons here, 7 newtons. Let's start with the first problem first. So, what is the rule of sum of moment about a point? The rule is that the sum of the moment about a point is equal to the sum of the clockwise moment about that point plus the sum of the anti-clockwise moment about that point. Well, in other words, if we are to take the moment about this point here, x, this force, 7 newtons, will be going towards this side. So it's going anti-clockwise. It's now going this way, anti-clockwise. You can't go all the way here. It's going that way, anti-clockwise. And this one here, since it's already hanging here, is going this way. So it is going clockwise. Clockwise, anti-clockwise. So this is what we're going to add. It's just addition. Simply, this is just algebra. So now we say sum of the moments about x about the pivot x is equals to, we'll take 7, or let's start with the positive one, 2 newtons. You know the moment is force times the distance, perpendicular distance. Force times perpendicular distance. This is already at 90 degrees here. You can see that. That's why they put this sign here, telling you that this 2 newtons force is perpendicular to the distance of this rod. That's why this is here. So you have 2 newtons times the perpendicular distance is 7 newtons. So sorry, 7 meters plus 2 meters, because you are taking your moment about this point x. So the whole length is 2 plus 7, 9. So 2 times 9. We now look at this force. So this force now here, 7 newtons, is going anti-clockwise because it's going that direction towards x. So you should have minus sign. So what is the perpendicular distance? It's 2 meters. So 7 times 2. This gives us 18 minus 14. So that you get 18 minus 14, you get 4 newtons meter. Because this is positive, so it means the sum of the moment about x is going clockwise. So it's 4 newton meter clockwise. If you don't put this, your answer is incomplete. If you don't put clockwise, the answer is incomplete. This indicates the direction of which the force is going. That's number 1 is done. Let's look at problem number 2. Again, they are the same problems, 1 and 2, or I and B. The only difference is this force here is being applied at an angle of 30 degrees to the horizontal, while this was 90 degrees to the horizontal. So we have done similar things resolving forces. So let's start. We are resolving these forces, or we are taking moments around the point X. So here we start again. Sum of moments. I hope you understand. Sum of moments of forces about X. I've left out the forces, but sum of moments about X. So again here we say sum of moments about X is sum of clockwise moments plus sum of anti-clockwise moments. So if you look at this one is going anti-clockwise. It's coming towards here, but it's 90 degrees here, so we will not have problem with this one. Yeah, but this one here, you can see the force is being applied at an angle, which means we need to resolve this force to the vertical axis so that we can get the perpendicular distance we are looking for. So we are going to resolve this force around here. This is the distance we are looking for, that dotted line. So the angle is opposite to that dotted line. Yeah, it's opposite. So we are using the sign identity. Yeah, so therefore we'll have 7 newtons times the sine of that angle, which is sine 30, now times the distance. That is just the force. This force will resolve it. Now we are assuming this force is here. This force is now acting vertically instead of at an angle. Sometimes the more you explain these things, the more you confuse people. I'm trying to draw this diagram. Correct. This is your 30 degrees. Originally the force was here, not so. It was acting here. But we've now resolved it vertically. So this force here of 7 newtons, it is now acting here 7 sine 30. Now what is mean? Now it is acting on this vertical line. We've resolved it vertically. It's now here 7 sine 30. That is what we call it now. Instead of 7 newtons here, 30 degrees here, it is now 7 sine 30. It's now acting there. That is the force. That is how we resolve forces. Yeah? It's another topic. Times distance, perpendicular distance times 3 about X, because from X to here is 3 meters. Now we come to resolve this 15 Newton force. It's going anti-clockwise. So because it's going this direction towards X, so we put a minus here. And the distance is 1.5 meters. So you have 15 newtons times 1.5 meters. This is all you need. And we know the sine of 30. You have 7 times sine 30 is 0.5. If you do your calculator, 0.5 times 3 minus 15. This is 22.5. Use the calculator. So now you have 21. Let's use the calculator. People always like to use calculator. Why not just calc? You have 7 times 0.5 times 3, which is 10.5. So here you have 10.5 minus 22.5. Oh, what do we have here? You get a negative sign, minus 10 newtons meter. That's the unit. But because it's negative, you have a negative sign here. So it means the sum of the moments about x is going anti-clockwise. So you put here anti-clockwise. That is your final answer. Thank you for watching. Bye bye.